Okay, there we go.
All right, so homework.
All right.
So part 1, just reviewing, it's basically just like copying down the table that they gave us during the textbook reading.
Yeah, that's what I did. I had already drawn it, so I didn't re-enter it all.
Excellent. Okay. So, and then they just kept stressing that we can only test the first 3, and the other 2 we can't get information from, right? Well, like, we can't test data on our program, right?
What do you mean?
Later, like when we put stuff through SPSS, we can test for the top 3 things, but we cannot test for like or observations are independent.
Yep, we can do the requirement of the linear relationship, the normal error term, and the constant variance.
Okay. Mallory just texted saying, "Go without me tonight."
Okay.
I still haven't heard from Andy, so.
Yeah.
Okay. All right. Anyway, okay, number 2. Okay, so this is where I get confused. What is y? Like, what are we trying to find with y? What is it?
Is it still just the y-intercept?
No, because that's part of x. Or is it?
Well, x is slope.
So x is slope, but like where the formula, it says y equals, and then it talks about all the variables. So like the first beta is the y-intercept, and the second beta is the slope, right?
Yeah.
So I don't know. I'm so confused.
I honestly, most of the time, don't understand everything. I just plug things in, you know?
Right. And that's what I did too. And it doesn't really talk about, you know, what the y represents by itself, but I don't know. So.
Well, because see, before, so on the last lesson, the y with the hat on it.
Right.
I have an equation here that says y with hat equals, well, that's a little different, but it's the b0 plus b1x, and I have it written that y predicts the body length of the crocodile, and x predicts the head length.
Right.
So that's a different equation, but it's like...
It's basically the same though, because I mean, the only difference that we're doing this time around is we're talking about parameter instead of the sample, right?
Yeah.
Right. So, okay.
So I think that must be, it's just the body length, I guess, in this case.
Right. Right. So, okay, that's fine.
That might not be right, but I feel like that equation's basically the same, just like a simpler version.
Yeah. So. Yeah, I agree. So, okay. Part 2. So it's check the 5 assumptions for conducting a linear regression on the data of the gharial crocodiles. And list the 5 assumptions below and explain how you checked the assumptions, include the charts, etc. Okay.
So the 5 assumptions, the first one is there's a linear relationship between x and y. The error term is normally distributed. The variance of the error term is constant for all values of x.
Right.
The x's are fixed and measured without error, and the observations are independent. But you can really only check the first 3, right?
Right. So the first 3, it wants to know the degrees of freedom as the third thing. So when it says the variance of the error terms is constant for all values of x, that's the degrees of freedom that it wants.
Oh, really?
Yeah. The second one, it wants the t, like t equals. And then the first one, it wants your hypothesis.
Where did I miss this? How do you know that?
I'm a big fan of all the PowerPoints that he does.
And I'm not very good at watching the PowerPoint.
There you go. See, that's like I watch that first, and then I read the chapter, and then I watch it again.
Oh, okay.
So he talks about that's the breakup of the hypothesis testing.
Okay. Because I just did I did the graph, and then you can see that it's like linear, you know. Yeah. So I just did it that way.
Okay. So yeah, that's fine. But it's still the same because your answer is right. It's just the three things that we test for, the three things that we're looking for are the hypothesis. So in other words, the significance, the level of significance, what the T is, and then the degrees of freedom. So, okay.
So I have a question, and I wrote this down to ask later, but so on the T, like you get 2 T answers.
Okay, so on your graph, you're looking under where it says coefficients, right? And there's 2 lines of numbers, right?
Yes.
Okay, so the bottom ones are what you're interested in. That has to do with your slope.
Yeah.
And that's mainly what we're talking about. We don't really care about the y-axis.
Because I had figured that out because, I just matched it up with the lesson, but I was just curious, why that one, or if it's always that one, or, that kind of thing.
Okay, so you're going to laugh at me, but I don't know if you can see.
Okay.
I did color coding.
Nice.
You see all that?
Yeah.
And I did a table over here to describe what the heck all of that means.
Well, that's perfect. That's totally my style. I totally have notes, and I highlight everything and do different colored pens and.
Yeah. So.
I will not make fun.
Okay, good.
And then, so similarly, on I think it's the same, but on Excel at least, and if this is the case, just tell me that it's not on SPSS, but so it gives you the p-value.
Right.
And it gives you 2 numbers, just like it does before. Oh, I see. Okay, never mind. I figured out my own. I just didn't see the E -23 thing.
Right. So
I was like, how is that? It just didn't match up with the answers, but I see now.
Right. So how you get that answer is if you double click on the 0.000, and then you double click on it again, it shows the actual equation. So it says E times, 13, whatever. And so that helps you know how many zeros to put down.
Okay.
So yeah.
Sweet.
I don't know how accurate it's going to make us be on the quiz or the test. If it's going to ever make us write out 13 zeros and then the numbers. But anyway, it's good to know how to do that. So.
Yeah. All right. So the null and alternative hypothesis, this is all the same from the lesson.
Yep.
It went over this one, but the beta 1, which is which one?
That's the slope.
Yeah. That it will equal 0, and then alternative is that it won't equal 0.
Right. And then the level of significance.
0.05. And then the test statistic, and I don't know what it was saying, the test statistic and value of the test statistic.
Okay, because it's asking which test statistic is appropriate, and that's why it gave us that. So it's a t-test.
Yeah.
That's, well, it wants the t, the t value. So it's.
So is that question, is it asking what I was asking before, which t to use? Is that what you're saying?
Yes.
Okay, so it's the slope one, not the y-intercept.
So, well, it's asking what test. So do you remember that table I was talking about last time? Which hypothesis test is appropriate to use?
Uh-huh.
That's what that is asking.
Oh, okay.
So the first part of that is asking, which test are you going to run?
Gotcha.
So, and it was attached to the group homework or group work. It says something like blank, I don't know, blank statistical test, something or other. It's a document that's at the bottom.
Okay, and that was attached last week?
This week.
Oh, okay.
This week. But again, it looks like...
Oh, I see. The statistical flow chart not filled.
Yes. So it looks like this. So I printed it out, and then I just filled it out.
Oh, man, that is intense.
Yeah, but it's really helpful.
Okay, I'll have to do that.
But, okay, there's a video on it.
Okay.
So
I remember you told me. I just haven't done it yet.
Yeah, no, that's fine. Gee, why not, Hannah? You're just sitting around. It's not like it's a newborn or anything.
So,
Okay. So yeah, that's where that question is coming from. It's just asking what test is this? So what's the value? What test statistic first? So you just say whether it's a Z-test or a T-test, and then you give the value of that.
okay.
So actually, you just let SPSS do all the thinking for you.
Mm-hmm.
Because if you do all of the data work, then it's going to say right there whether it's a Z or whether it's a T.
Gotcha.
So.
Yeah, I've emailed the teacher, and surprisingly, she hasn't gotten back to me. And I've also emailed IBM because I cannot figure out how to get it to download on my computer, and it's so frustrating because I should have done this forever ago, but
Yeah.
I don't know. Hopefully, I can get it in the next day or two so that I can start practicing with it.
Yeah.
Because
I didn't look at what Thursday's schedule is, but this was the last PowerPoint.
Yeah. No,
So
Thursday is just review and the group project.
Yeah. So yeah, I think we're almost done. So
no, that's nice, and I like that for this test. There's only 4 lessons.
Yeah.
But that's nice, except for the part where they always have questions from. It all builds upon each other,
It does. It does.
I can't get away with just knowing this stuff.
Yes. Which is annoying.
But on the last test, I had my husband's laptop pulled up because you know how you can do that desktop thing and use BYU Idaho's desktop to use SPSS.
Oh, okay. I've never done that.
So you can have access, it's like you're logging onto a BYU Idaho computer.
That's
nice. So I had the numbers tiny, and I just entered them into Excel one by one. So if I misentered one, then the whole thing was screwed up.
Wow.
So I'm hopeful that we can figure that out.
Yeah. Gosh, how frustrating.
Yeah. But I emailed her and asked for suggestions, so hopefully she'll get back to me. But
yeah, hopefully.
See. Anyway.
Okay. So for D, so our T value was 22.675.
Wait, what did you say?
For C, I got 22.675.
Oh no. 22. I wrote down 35.588.
Oh. Could you have written down the wrong one? Because we just talked about the top.
Well, the top one is negative 1.834.
Okay, let me go look.
And when we did it in the lesson, I wrote it all down. And I still could be wrong. I don't know if I'm writing the wrong numbers, but so in the lesson, it gives the example, and you work out. And we wrote down T equals 35.588.
Okay. So if we go, hang on, I've got so many SPSS documents open right now. So just hang on with me until I find the right one. This is looking, okay, gharial crocodiles, and I have the T value 22.675. Yeah. So, and then hang on, I'm going to check the answer key.
Okay. Well, I trust you more, so now I'm just concerned what I did wrong.
Yeah. Okay. Yep. Mine. It's 22.675 and the answer key as well. Gosh, Hannah, I don't know.
Okay. I'll figure it out.
Okay. Yeah, if you go through his SPSS, if you get SPSS to work somehow, if you go through his instructions, his video on SPSS, it walks you right through how to do it.
Yeah.
Gosh, I'm sorry.
No, you're totally fine. I just wrote down, like, I was kind of following the lesson too, but maybe I put the input the data wrong.
Yeah.
I'll figure it out. It's not a big deal.
Okay, so p-value 0.000.
Yeah, so either way, we're going to reject the null.
Right, reject the null.
So we have sufficient evidence
to suggest there is a linear relationship between the head and body of the crocodiles.
There you go.
Right?
Yep.
Okay. Confidence interval. I got 6.704.
Let's see, what was mine?
Hi, babe.
See, I wrote it down. You got 6 point what?
6.704.
Okay.
And 8.90. Sorry, 8.096.
So I think mine is still just messed up, so I'll have to figure out.
Okay.
And maybe I just need to recopy and put the stuff in.
Yeah, maybe.
But I'm sure you're right.
Yeah, I checked the answers. It's the same answers.
All right.
Oh, nope, I lied. There's a slightly difference. Isn't that interesting? Oh, okay. So it says Excel gives 6.712 and 8.089, but I did SPSFs and it says 6.704 and 8.096. So
Okay.
that's what I got.
Mine must just be slightly wrong. I don't know. Maybe like I accidentally clicked on the data and messed it up or something, but
Anything can happen.
yep.
Okay. Quiz time.
Okay.
Okay, so it's the third one, right?
Mm-hmm. What are the null and alternative hypotheses for B1 or beta 1?
Right, so it's the third one.
Yep.
Beta 1 equals 0. Beta 1 does not equal 0.
Yeah.
Okay.
A residual is
It's the difference between the observed value y and the value predicted by the regression line. That's what I have.
I just am trying to find where I wrote it down. Yeah, the difference between the value of y and the value that would have been predicted, by the regression line. So B.
Yep.
A plot of residuals supports using linear regression when you don't see a pattern.
It's right. So it's when you don't see a pattern, so you know it's not the first one.
Yeah.
The residuals are all positive, doesn't even make sense.
The residuals look normally distributed.
Yeah, that's the right one. With zero mean. Because remember the zero mean, there's a line that goes through it, and there's like it's from the 4th page of the textbook that I found that.
Yeah, I have a little picture.
Yeah.
That graph.
Yeah.
Okay, compute the residuals for the math self-efficiency data. Let me pull that up.
Okay, so are you doing Excel still then?
Yeah.
Okay. It would just be nice, to be on the same program so we could walk each other through.
No, trust me.
Sorry. Okay, I got the residuals form a linear pattern because I did the QQ plot. And then I did the residual QQ plot, and the residuals followed a line.
Okay, I'm putting it in right now.
Okay, that's just fine.
I'm hoping that like I can catch on to the SPSS pretty quickly.
It's so easy.
I always read through like the little like, not always, but sometimes I'll look and see like when it gives Excel instructions and then
Right.
SPSS, and I'll look at it and it's like click this, click this, click this, and then it's done.
It's so true. And
it's probably easier than this, but I'm hoping that it's not like so hard to learn.
No, it's not. I mean, it's honestly, from day one, it was seriously just open it up and click on the right words and it will do all the math for you.
Yeah.
I like that.
So I just need to learn like what to click when, you know.
Right. Right.
Okay, so I got, what's the question?
Compute the residuals, use the confidence data as explanatory, and the score data as the response variable.
This is the one that we switch, huh? They're backwards.
So, yeah, I do. I know what you're talking about. I wrote it down here.
I like that at least most of the time they're in the right order.
Yeah.
Okay. What is the statement best describe? What statement best describes residuals?
So I put the residuals form a linear pattern because the residuals are not all negative.
No.
And the residuals are not between -40 and 25.
Yeah.
So
I'm just doing the graph real fast.
That's just fine. Please do.
So, yeah, so you just did that same residual plot, right? Where it has the 0 through the middle?
Yep.
And then, like, there's no linear pattern, right?
Right.
So why is the answer the residuals form a linear pattern?
Oh, you're right.
Since they're just like all over the place, right? They're not supposed to.
I was thinking of the QQ plot.
Yeah, because my QQ plot there, it's linear.
Right.
I want to make sure I'm doing the right thing.
Yeah, no, you're right.
So I would say, where'd it go?
Okay, math efficacy. Hang on, let me go find it.
They are between -40 and 25. That looks about right.
Come on. There we go. Okay. What was the range again?
-40 and 25.
Okay. Well, yeah, close. I have -38.2 to 23.422. So yeah.
Yeah, and I have the same thing, but
Okay.
it just says that they're about. It says or between about -40 and 25.
Yeah. Yep. Thank you for catching that. I was totally thinking it meant QQ, but you're right. It's the opposite. So
yeah. So QQ is the next one.
Yeah.
And that's just the one that has the line through the regular data, right?
Right.
So
It's not the regular data though. It's the residual. So you have to do a QQ plot for the residual.
okay, so
I can tell you how to do it in SPSS.
let's see.
And I can
yeah, it says for the residuals. So can you say?
Yeah.
So all I do is because I already have the QQ plot, so you just see that line goes through it, right?
Right.
Like
for SPSS, it has you. There's a part that's called unstandardized.
Mm-hmm.
And that's what it means by the residuals. And so if you want to do the unstandardized test, you click on it. And so it's a QQ plot separate from the normal data that gives you the residual information.
Okay.
But they pretty much matched each other, the QQ plot for both. So yes, it's fairly normal.
Okay. Let's see.
So number 8, use software to create a scatter plot of the math I cannot say this, efficacy data.
Yeah, I always say efficiency. And
I know!
That's not right. Like when I look closely at the word, I realize that that's not what that says, but like that's just what I naturally read.
Okay, so this is the 5-point test. So it wants us to run our data. But you know what? We don't even have to run the data to answer this question.
No.
It's just a trick question. It's just asking which 3 are the data going to provide answers for, and we know that it's the top 3.
Yeah.
So it's the linear relationship, check. The residuals are normally distributed, check. The variances of the error is constant for all values of x, check. And then the other 2 we do not check.
Yeah.
Do you agree?
Sweet.
That's how I understand that question.
Yeah, no, I agree. Which of the 5 assumptions about linear regressions are satisfied by this data? Yeah. Like those other ones may be right, but it's not satisfied by the data that we're looking at.
No, it's not satisfied by the data, and that's kind of the point. We can't prove it with the data.
Yeah.
Okay.
Okay. What is B1, the estimate for the slope?
So are we still talking about math self-efficacy at this point?
I think so. They usually like tell us when it changes.
Okay. So I got 12.695.
Okay, and I have 12.725.
Okay, so yeah, that's hopefully they accept both answers, but
remember last time we found in the last lesson that they do because
they do. That's right.
Yeah. Okay,
In fact,
this one will tell me if I'm doing it right, and maybe the last one I just accidentally messed it up.
Okay.
Because now I seem to be getting the right answers as you, and I didn't do anything this time.
So
confidence interval.
The range that they give. Go ahead.
0.708 and 14.742.
So the interesting part is these are Excel ranges because my ranges weren't here.
Okay.
The closest one was 10.708 to 14.742.
Is it very far off for you?
It's about a 1/10 off. So
okay.
no,
it's not huge.
It's not too bad. But I panicked because mine started with 10.598.
Yeah.
And 14.8 something. So it's like.
So why would they put the Excel answers on here when they don't want us to use
I don't know.
I wrote her not really this sob story, but like I've been working pretty hard in this class. Like I'm not doing well because of the SPSS thing.
Right.
And so I was like, is there any way that I can like have access to the Excel files for the test, or can you like help me figure out how to get it downloaded? You know, I just don't understand like why do they use that if that's not really what they want us to use?
Yeah, I agree.
Well,
yeah. Okay, so based on the evidence and using level of significance 0.05, what decision would you make?
So I have that P is a crazy low number, so
right.
I would reject the null.
Because the p-value is less than.
Yeah.
Yep, that's what I did too.
Sweet. Okay, and then I would say that there is sufficient evidence to conclude that the, let's see which one.
Slope of regression line is not 0.
Yes. Wait, what's the evidence? There's. Okay, the other one is 0. Okay, I see.
Yeah.
Okay. And then for the crocodile one, which variable is the dependent variable?
So the dependent is our y variable, so that's going to be our body.
Okay. Since the 99% confidence interval for these data, what is 7.1248.311? What can you say about B1? Ooh, I don't know.
Okay, so this one,
I do know.
I was going to say, I know I had read it, and I know I had watched a video on it, so I had to go find it, but it's definitely the first one.
Oh, really? Since the conversation. Oh, that makes sense because it's between 7 and 8.
Right. So right on the PowerPoints that he does, I like his PowerPoints because he sums up the lesson in 4 pages. And so I just print those out and I highlight everything and stick it in my binder.
Maybe that's what I'll do for my review is I'll go back and watch all the PowerPoints.
Yeah, that's not a bad idea. Okay, so it says right there, since 0 is not in the confidence interval, we can say that beta 1 does not equal 0.
Okay.
So
I just remember we had like a million of these questions in the beginning.
Yeah.
And I would always say there's 99%.
Right.
I guess not really that one, but I would always say like there's 99% chance that all data lies within 7 and 8. Isn't that what it is? Something like that.
Yeah, something like that. Though that still messes me up on how to say it.
Yeah, well, and I would often get them wrong and then like be like, wait, that I feel like that like because they all would give all the answers would be so similar.
Yeah. So Hannah, we got 100%. I just pushed.
Oh, good. Sweet.
We're rocking it. Woohoo!
And then, is there anything else on the group project?
I haven't even looked. I usually look on Thursday for that. Okay. So yeah, sorry.
No, that's okay. It's just that it kind of threw me off because lesson 24 is project presentations.
Right. So well, the only thing that I see on our schedule is make inference. So I guess we are to that point.
Yeah,
right?
And then we probably put it in a PowerPoint or whatever.
Right. And I'm doing the inference part.
Okay.
So this is my week.
That's probably best because that's probably going to be the hardest.
So did Andy ever get you his data?
Yes, he did.
Oh, good.
And I'm really hopeful. I ended up emailing it to her. I was having a hard time uploading it, so I emailed it to her instead. And we know, I'm just worried that she might not see it. So.
Okay.
Don't panic if you get a 0. I did turn it in.
Okay. Well, because Mallory texted me and she's like, well, what are we supposed to put on our assignment? Because, you know, we're not turning it in. And I'm like, all I did is I just typed in Hannah from group 13 will be turning it in for us. Yeah. And I pushed submit so that at least she could see that. So. Yeah.
So as long as she finds it in her email, then we'll all be good.
Yeah. Okay.
Sweet.
All right.
Well, I'll see you next week, and I'll upload this to the.
Okay. Sounds great. Thanks, Hannah. Have a good night.
You
Bye.
too.